Welcome to Introduction to Microservices Architecture Basics series of videos. I'm Mustafa Rifat. I have been designing and developing software solutions for more than 20 years, and I acted as a referee for the IEEE Software magazine before. You can find more information about me on LinkedIn profile or on my blog mustafarifat.com. In this video series, I will go through the principles of designing software applications or solutions using a microservices architecture approach, abbreviated as MSA. Now, software architecture is about making choices or decisions of how the software is composed and structured. These decisions can be costly once they are implemented if you want to change them. So you are selecting how the software will be composed, what are the structures, and the documentation would act as the blueprint for this solution that the developers and program managers will use to build this software. Software consists usually of many lines of code, and it used to be done in a structured way all times. If you looked at old code, COBOL and stuff like that. In the late 80s and 90s, started with the object-oriented concept of getting the software, the code with the data, encapsulating the data inside code as objects, calling it classes, and using these classes together to assemble some operations or some systems and stuff. And that's the main principle, how to produce components that we can integrate easily together. This led to the components and packages layers and the DLLs and jars and COM objects in the 90s and 80s, and you would buy some components for UI or for some business logic or stuff from vendors like Microsoft or Sun or Oracle, and you would use these to assemble they'll act as part of your framework or build bigger systems. And the software you would write components or DLLs and try to assemble them. This was fine when you were working on only one computer and one system. It led to a little bit problems. As more and more complex software we started developing, came the service-oriented architecture, which is basically, instead of DLLs and components, we will have services. We call them services now. And these components or services, they will communicate with each other through either HTTP, web services, SOAP, which is most used for service-oriented architectures, or remote procedure calls. However, service-oriented architecture got a little bit bad implementations and got bad reputation. So now came something called service-oriented or microservices architectures, which is a variation of service-oriented architecture style. Structures and applications as a collection of loosely coupled services, which is basically what service-oriented architecture was trying to do, but because there wasn't good guidances or people were just learning it, they didn't implement it correctly. It encourages using lightweight protocols for communications between them. We will look later on at a service-oriented approach application and how a microservices approach would be a little bit different from it. It increases modularity, which was from the way people were doing structured programming to object-oriented programming to packages and layers, DLLs. It's all about how to isolate components and software and have components as plug-in like Lego that you can assemble bigger system with that you can easily modify. Microservices has many advantages that paralyzes development because you are completely separating stuff, you're separating components. You can have a team working on a component and another team working on a component. Deployment and scale independently each microservices, that's one of the big differences between it and service-oriented architecture. And it has independent internal architecture, which is basically each service can be built with different technology stack. That's a little bit different from service-oriented architecture. Yet people in service-oriented architecture says, well, all this can be applied to service-oriented architecture, but the difference is that microservice puts a little bit of more constraints or insights into how to build things. It enables continuous delivery and deployment, and we will see this later, maybe not in this video, maybe in other videos. So here is a typical SOA approach or service-oriented approach. You see that we have UI, web UI application, we have a gateway or ESB, we have an ESB approach, which is a kind of a heavy logic middleware, and we have multiple services. Each service is considered to be a kind of a domain, you know, accounting service, order service, stuff like that. But you will notice they are all going against the same data store or database, and they are all, most of the time, they are all built with the same technology stack. So the IRIs are all .NET or Java stack, and there is some tight coupling between the libraries they are using, and they are usually, all these services, they are sometimes are deployed as a big chunk together on one system, which is a problem. We will see later why, because if you want to scale, you have to deploy everything to all these other nodes, and that would be a waste of resources. The microservices approach has a different perspective, which is it isolates each service, tries to make each service have a single responsibility, so it's more fine-grained, and each service is completely contained. Each service has its own data store, and notice here I'm using data store, not a database, because you can have service A using Microsoft SQL, service B using MySQL, service D using say Hadoop, for example, NoSQL data store, and they usually communicate together through web services. So because you want to have all the communication protocols technology independent, you cannot use RPC and the remote procedure calls, and usually they can have different stacks because they are deployed in different nodes. So most of the communications are going through either queues like Kafka or service bus or something like that, or through REST APIs, which is called web APIs for some reason now. That's the branding for them. So why MSA? Why is it so popular now? And why people are so, going through it? Because basically, microservices architecture gives you a few advantages. You can change or modify each microservice independently, and that's because most of the products now are SaaS, software as a service. You can provide upgrades quicker to your clients, and because it is easier to incorporate new technologies, and you have more business domain-driven design. We will talk about domain-driven design later on, maybe in another video. And because we have now automated testing tools, which enables us to testing all these microservices and the communications between them. And it's easier to adopt new technologies. You can easily, there is the latest technology, so each team is independent from the other team or developing other microservices, so you don't have to keep everything at the same level. So we have all the components have to stick with, say, .NET 3.5 or Java 7, Java EE 7. No, you can have different technology stack. You can have one that Java 8, one that is .NET Core 2, one that is Angular, etc. And of course, the rise of asynchronous communications enables all this and makes it working. So to recap, microservices architecture benefits are: each service is relatively small, so it's easy to manage and solve and evolve. So it is easy for a developer or a group of developers, small group of developers, to understand it and get started quickly with good productivity, and they can finish it. Each service can be designed, developed, deployed independently, and that's make it easier to have distributed teams. You can have teams working in North America, teams working in Asia, teams working in Europe, or in different cities, or in the same stuff, but they are completely independent. And you can use different technologies, and because you are using different technologies, and each microservice or each service is its own domain, its own life, its own node, you can use the latest technologies that are suitable for this service. And because each service is completely independent, you can easily scale each service and differently. So you can have service A, you can have 7 nodes of it, and service B, you can only have 1 node. So that is different from service-oriented architecture, because services were kind of little bit tightly coupled, so you had to deploy many of them together. One of the cons, there is nothing for free, you know. So microservices architecture introduces some cons, which are because they are distributed applications. So transactions between them aren't, atomic transactions aren't usually possible. So business has to be okay with eventual consistency. Distributed applications introduce complexities for developers when they are building and testing the services, and how to act with exceptions handling and latency. And there is deployment complexity without tools to automate this deployment. There is problems with that. As I mentioned before, you can have each service by itself, so there is increased global resource needs, but this as hardware is cheaper these days, and the increased ability to reuse this hardware or to deploy more nodes, it makes it easier. So it pays for itself in the long run if you have many microservices. And there is the need for API gateway, which is because different platform or different applications, users or clients, would have different needs. So for example, if you have a mobile app and a web app, usually you would build a kind of a facade or API gateway for the web UI, and another API gateway or a facade for the mobile app, because their needs would be different and there would be gross-grained communications between them. Application partitionings, how are you going to partition applications into microservices? That's something, it's not that hard, it's not that easy either, because you keep evolving the system and you see that there is an entity or a component or structure that belongs here, but it might be better in the other microservice, and then you also find that different entities are appearing in different microservices, and we will talk about this when we talk about domain-driven design and business context. Another thing is that because microservices architecture discourages the uses of the ESB, and many organizations have big ESBs, but using the ESB was kind of a bottleneck, because if you are using ESB to communicate between microservices, the ESB team usually in big organizations isn't that big and cannot handle all these requests for changes and stuff. So usually with microservices you stay away from the ESB, you use some kind of other communications. We'll talk about that in the communications module. I hope this was a quick introduction for you, and thanks for watching. In the following videos I will address all the concerns and discuss the various design patterns associated with microservices. Don't forget to subscribe to get notifications for the next videos. Thanks for watching again, and hope this will help you with your project. If you have any comments or thoughts about these videos, please don't hesitate to contact me, and thank you.